Okay, so yesterday we left off with example number 3. So exponential growth and decay. So it's not important to know if it's growth or decay. That's not the really important part. The important part is when do we use the stuff we're using, the methods, the steps that we're doing today. So we talked about some keywords, right? Is directly proportional. Anytime you have that, you're going to be using this. Okay, so the first thing we got to do is find a formula or find an equation that's going to help us answer the question. Sometimes they won't have you do part A and part B, they'll just ask you part B. That's fine, but it's not shortening the problem because you always have to do part A. You can't find the answer to 1,000 years unless you have actually found the formula or the equation. Okay, so yeah, sometimes most so for like multiple choice questions, they won't have two parts. Obviously, they'll just have one part. They'll say find the mass after 1,000 years, and they'll have A, B, C, D, E. But if you don't find the formula, or if you don't do what we've done here in part A, you're not going to be able to do that. Okay. So I've kind of scaffolded it into two parts, but um, yeah, for that reason. Okay. So we found part A, I believe. We found K, right? We found K. K was 1 over 1,590 times the natural log of 1/2. Okay. So then what I did was I put it back. That's the answer to part A. Notice how I didn't change anything to a decimal. You don't change anything to a decimal until the very end, until you have your final answer. That's the only thing you round. Okay. So when I'm putting stuff in my calculator, I'm not changing any of these fractions to decimals. Okay, I'm not changing any of these guys here to decimals. I'm putting them in just like that. Okay, because what happens is this guy is a decimal that goes for a long time. If you put this in your calculator, it's going to be probably a non-repeating decimal. This guy here too, same thing. Because this is an exponent, it's going to magnify any kind of rounding error not rounding error, but rounding that you have, right? So we don't want to do that. We do not want to do that, okay? So last thing we have to do is plug in for t. We know t is going to be, for this guy here, we know t is 1,000 years, okay? So let's plug it in, and then we'll take out our calculators and do the rest. Okay. Okay, so when you put it in your calculator, so when I put it in my calculator, well, you can do this problem. Here's the thing: you can plug in all of these things on a regular scientific calculator. All right, TI 30 calculator. You don't need a fancy dancy calculator for that. Okay, um, but I'll show you. I'll show you how I do it. I do it piece by piece, like I told you, piece by piece. So what I'm going to start with is I'm going to start with the natural log. So I'm going to put natural log of 1/2 in my calculator. Okay, and then work my way out. So this is what I do. I go natural log 1 divided by 2. Okay, it's a negative number. And then what I'm going to do is I'm going to multiply that. So if you hit multiply, it'll take all of that. It won't round it. It'll take all of that and multiply times the fraction. 1 divided by 1590. I believe that's the fraction. Yes. Okay. What does that e mean? See, I have e to the -4. What does that mean? Does anyone know what that means? E to the -4. If your calculator ever does that, is that what you know? Anyone know what that means? Mhm. Yeah, it's scientific notation. It's scientific notation. So scientific notation, instead of 10, you guys are probably used to seeing 10 to the -4. This one has e. It's the same thing. So negative means we go to the left. So this number here, I would go 1, 2, 3, 4, and fill those in with zeros. So -0.000, and then that number there. So it's a small number. It's a really small number. Okay. All right. Then I'm going to multiply that times 1,000. Okay. That's my power. That's my power. So now I'm going to go E. So E, like I said, every scientific calculator out there does this, has an E button. Okay. And then the last thing is multiply by 100. Well, when you multiply by 100, it just moves decimals to the right 2 spots. So you get 64 point. Now this is the one we're going to round. This is the only number we're going to round because it's our final answer. We're done with it. Okay. So I would say approximately 64 point. You should always go at least 3 spots. So 1, 2, 3 grams. Is it grams? Milligrams. Okay. So is that the only way to use the calculator? No. A lot of people like to put it all in one big chunk, and it works for them. Great. But I've seen also people try to put it in one big chunk, and then there's a parentheses missing somewhere, and the calculator gives you the wrong answer. Like I had a student do this. I had a student in my math 3 class. She did this. She had this answer here. One of the problems was she had to do this here. So she put it in her calculator, and the calculator gave her that. She got it wrong because it is wrong. Actually, it's correct. Actually, that's correct. If you put that in your calculator, that's the answer you will get. Because the reason why, so watch, -4, maybe I've showed you guys this before, squared, you'll get -16. Wait, -4 times -4 is not -16. It's +16. So why is the calculator giving me -16? Exactly. Your calculator knows PEMDAS better than you sometimes. Because this guy right here is not -4 times -4. It's -1 times 4 squared. So if you want to do -4 times itself, you got to use parentheses. That's telling the calculator there is no -1 in front. It's -4 and that's it, right? So you got to be careful, okay, with when you put things in the calculator. Okay. Okay, so let's go back. So you should always do a check for, does that make sense? So we set up here that our answer is about 64.6. Does that make sense with the other values they've given us? Does that make logical sense with what they've given us already? What they gave us at the beginning? Does it fit the table? Yeah, I would say it fits the table, right? 1,000 is closer to 1,590, so 64 is closer to 50, and it's in between them. Yeah, that makes sense. Okay, so our answer makes sense. Okay, all right, so now question C. When will the mass be reduced to 30 milligrams? When will this number, when will R equal 30 milligrams? That's what it's asking for. So now what are we solving for here? We're solving for T, yeah. We're solving for T. So we're going to use the same equation that I used earlier. This guy right here. Except we don't have T. We have 30. We have to solve for T. Again, this part right here has nothing to do with calculus. This is not a calculus question here. Solving for a letter, that's algebra. Math 1, Math 2, Math 3 type stuff. Okay, I'm just trying to isolate T. That's all I'm trying to do. So if I'm trying to do this, what do I got to do first? If I'm trying to isolate T, get T by itself, what do I do first? Again, not a calculus question. Divide by 100, good. Start with that. Divide by 100. Three-tenths. So I'm not going to change it to a decimal. I'm just going to leave it as 3/10. Okay, so what now? There you go. Convert it to a natural log. So we got to convert it to a natural log. So the question is going to say natural log of something equals something. Question is, where is that something and something going to be? Well, this is a base. This right here is going to be, so this is the base here. So then you go here, and then you go here. So we start with the base, go there, finish with there. So 3/10 is going to go here. And then this stuff here is going to be moved down. Okay. Solve for T. Well, I got T on the ground now. So now I can divide by everything I don't want. Because it's all multiplication. So now you're just left with T. Well, this right here isn't that bad because your calculator can do all of this here. Okay, just for time purposes so that we don't take up too much time using the calculator, I'll give you the answer. So you're going to get about 2,761.775 years. Okay, that's how long it would take until 30 milligrams is left. 2,761.775 years. I should put the wavy symbols because it's not exactly. Oops. Okay. All right. Okay. So I want you to do now. Let's see. What's this one? Let's skip ahead to number 5. Number 5 is more similar to what the one we just did. Is it exact? I don't think it's exactly like it. No. Very similar, but not exactly. So we'll come back to number 4, but I want you to do number 5 on your own. I'll give you about 5-10 minutes. I want you to do number 5. Answer number 5 from beginning to end. It's only got one part to it, but you're going to have to do 2 parts. You're going to have to come up with the equation first, and then you're going to have to solve the question. Okay, so I didn't finish, but at least I got some of the, I didn't get the equation yet. From now on, when you're doing these problems, you got my permission. You do not have to do this stuff over here. If you want to, it's fine. If it helps you, you can. But this is always going to give you the same answer, right? R might not be R, depends on what we're talking about, and it'll always be T up here. But whatever, you know, this one's a radium, this one's another radium question, so this one's R, but it might be different. But if you separate here, you're always going to end up with this here. Okay, it's always going to happen. So if this part here, like I said, is optional for these problems from now on. Okay, you don't have to do it. You can, like I said, sometimes it helps because it kind of gets the ball rolling, but you don't have to do it because we always end up with the same thing. Okay, so they told me at present time it's 60 milligrams. It's got a half-life of 1,690. Okay, so that means half of its life is still there after 1,690 years. Okay, so after 100 years from now, how much is going to be present? Okay, so I plugged in 0, 60, and I got A is 60. So now I got to plug in the other point to get K. So the other point is 30 for R and 1,690 for T. Okay. All right, divide both sides by 60. I get 1/2 equals E to the 1,690K. Anytime I want to get, if I want to get a exponent down, I got to use a log. So to use a log, 1 second, let me get some extra page here. So to use a log, I'm going to have to go, the log is going to have a base of E. That's what it's going to be equal to. What the heck? There we go. It's going to have a base of E. That's what it's going to be equal to. And that's what the log of it's going to be. So it's going to be log of 1/2. Natural log of 1/2 equals 1,690K. So the log of natural log of 1/2 equals 1,690K. All right. Divide. And K is equal to 1 over 1,690 times the natural log of 1/2. Okay, so that's my equation I'm going to use. Let me go change K over here to what k is. 11690 times natural log of 1/2. Okay, that's my equation I'm going to use. The rest of it is just calculator work. Oops, should use a t in there. Need a t in there too. T. The rest is just calculator work from here, because now you have to plug in 100 for t. Okay, so we have r equals 60 okay, plug in 100 there. The rest is just calculator work. That's all I need to see on your paper is what you put into the calculator. And then from there, you just use your calculator and you get 57.589 milligrams. If your change off, if your change off, what I mean by change is this guy, these guys over here. If your change off, it's okay. That's just a rounding thing. Okay, change off is okay. Like you have 59 or 60 instead of 589 or something like that. That's okay. All right. Okay. We're gonna do, I think, one, maybe two more if we have time. Couple new ones. So let's go back to the one before that, number 4, population. Most of the questions you get for exponential growth or decay are either going to be population related or some sort of bacteria or some sort of element like radium, right? Bacteria or population. Almost all of the problems deal with exponential growth deal with those three things. Okay? Because population grows and decays exponentially. Okay? So the rate of increase of a population of a certain city is proportional. There we go. There's our is proportional. So now we know we're going to use this to the population. If the population in 1930 was 50,000 and in 1960 was 75,000, what is the expected population in 1990? Okay, this is a very common problem for cities. Cities have to know how many people they're going to have in 50 years, 100 years, because they have to get ready for that. They have to prepare for that. Okay, so one of the ways they do it is by using what we're doing now. Okay, so in 1930, the city had 50,000 people. In 1960, it had 75,000 people. So in 1990, what did they expect? What did they expect to have based off those numbers there? Okay. So we have to fill that out first so we know what letters we're using. What's our independent variable? What's our dependent variable? T? Mm-hmm. Because we're talking about years. Mm-hmm. There you go. I'm going to use a big P for population. Good. T and P. Population, people, the amount of people. Okay. Now you can separate here. That's fine. But like I said, or we can just cut to the chase and say, what are we going to get when we separate? What are we going to get if we were to separate P's on the left, T's on the right, integrate, solve for P? What are we going to get? There you go. If you didn't know that, that's okay. Just do separation of variables here. Okay? Just do separation of variables. It'll take you another 3 minutes, 4 minutes to do it. Wouldn't you rather take that extra 3 or 4 minutes and get the question right than not? I'm telling you right now, I'm grading the tests you guys took. Couple points here and there is the difference between A and B and C. Okay, so there's a couple people who missed a couple points here and there, and their grade just went down a little bit more than they wanted to because of those little things. Okay, so if you have to do those little things, do them. Okay, take the time. Okay, you have plenty of time on tests and quizzes. All right. Okay, so time. So 50,000 people, 75,000 people, question mark people. That's what I'm asking. So time. So I have 1930, 1960, 1990. Is there a better way of doing time? Those work. Yeah, I was thinking the same thing. Make 1930 the start, because I don't want to have, I'm already plugging in some big ugly numbers into my calculator. I don't want to have to make them even bigger, right? 1930, 1960, 1990, those are big numbers. So instead of that, since 1930 is the first day they gave us, let's make that 0. If that's 0, what is 1960 going to be? 30. And then 1990? Okay. Much better. In my mind, now is it wrong if you did it the other way? No, it's not. But you guys have seen the kind of numbers we're plugging into our calculator. Let's try to minimize that. Okay. All right. So we need to solve for A, we need to solve for K, and we need to solve, we need to solve for A, we need to solve for K. So let's start with the first one, initial. So 50,000 A e to the K 0 power. That's the initial. 50,000 is our initial. Okay. So far we have P equals 50,000 e to the KT. Plug in the next one. Let's see here. So we're going to plug in 30, 75,000. Move this over here. So now we're going to plug in 75,000. 50,000 E, and then we're going to plug in 30 T. No, not 30 T. Sorry. $50,000. $30K. When I plug in 30 for T, and I plug in 75,000 for P. Okay, so I'm going to solve. Divide by 50,000. So really it's just 75 divided by 50 when you cancel out all the zeros. That's going to be 3 over 2. Leave it as 3 over 2. Don't change it as a fraction. Or a decimal, sorry. Leave it as a fraction. Oops, I forgot the E. Okay. Log, natural log. This is our base. That's what it's going to be equal to. That's what the natural log is going to be. It's going to be natural log of 3/2 equals 30K. Okay. So the natural log of 3 over 2 equals 30k. Divide by 30. I get k equals 1/30th natural log of 3 over 2. Okay. So now I'm going to fill that in over here. Now I'm ready to roll. Now the rest is just calculator. Okay. So the rest, like I said, the rest is just calculator. So now what we got to do is plug in 60 here. Now I'm going to plug in 60 here. Multiply, do exactly like we've been doing. Okay. Since the rest is calculator, and I want to make sure we get to one more problem, I'm going to just give you, fast forward a little bit. That's what you'll get. Okay. When you plug in 60 here, 60 for t. When you plug in 60 for t, you will get this as your population. Okay. Okay, so I want to get to one more and then we'll be done with these notes. Okay. That'll be it's the number 6. Yep, number 6. Because number 6 is a little bit different. Same idea, a little bit different. Okay, so what I want you to do is read it, set it up, do your thing. Is proportional, so it's the same type of problem, so it's not a different problem. So set your problem up. D what over D what equals K times what. Set your table up. Your table is going to be what's given. We use the table for given. So what is it going to be? D what over D what? What's the independent variable? Time. Yep, time again. This time hours. Instead of years, it's hours. Good. What is the dependent variable? Yeah, I'd say B for bacteria. Okay. Again, separation of variables. Move the T's to the right, move the B's to the left, integrate, solve for B. When you do that, you're going to get B equals AEKT. Okay? But again, don't take any shortcuts. If you need to do that, do that. If you're like, I know it, then don't have to do it. I'll leave it up to you to decide. Okay? Given. So given, so they say at the end of 12 hours, there were 10 million bacteria. So at the end of 12 hours, there were 10 million. The question is, how many were initially present? Okay. But then they also give us another one, right? They also say it's triples in 4 hours. So the amount is going to triple in 4 hours. So that means in 4 hours, what is the amount going to be? What is B going to be? We don't have a number, but how can we write it? Hmm?
Can we make the question mark the variable and then 4, 3? So
There you go. Yeah. I was going to say, yeah, 3 question mark, 3 times the question mark, right? That's what it is. It triples, right? So just like Sebastian said, let's make this guy a variable, right? It's going to be A, right? Because that 0 is the initial amount, right? So that's going to be A. Let's just use A instead of picking a different variable. So this is going to be 3 times A. And 8, it's going to be triple that. So it'll be 9A, and so on and so forth. Okay? But that's when we'll stop there because we usually just have 3. Okay? All right. Let's start plugging stuff in then. So we know that at 12 there's 10 million. Initially, we don't know how much there is. That's actually what the question is asking, right? So this guy right here, 0, A. And then we know it triples. Every 4 hours it triples. So we still need A. We still need K. So what can we do?
can you do that?
Okay, that's another way of doing it. Yeah. We're not. Yeah, that's a way. That's another way of doing it. Yeah. No, you're right for sure. Well, can't we plug in the numbers that we have right now? Can't we plug in the numbers that we have? Right? We have some numbers, and then some we have variables. Well, we can plug in variables. So let's start plugging them in and see what happens. Okay. Anywhere I see, let's see here. So I'm going to plug in. Let's plug in 12 for T and 10 million for B, since that one's a solid one we have. So 10 million and 12 for T. Okay. See what happens. Well, it's going to be tough because I have 2 variables. I have E and K, A and K. A and K are both numbers I don't know. So I could divide by A. But it ain't going to help because I'll be able to solve in terms of, right? And then then it would be the natural log of 10 million over A equals 12K, divide by 12, but I don't know A. So the first thing I need to do is find A. Okay? So let's try plugging in something else. Let's try plugging in 0A. Let's try plugging in 0A. See if that works. So if I plug in 0A, what would that look like? Write it down on your paper. What does that look like? Hmm? A equals A. We know that already, right? We know A equals A. So when we plug in 0, let's see here. So A equals A to the K, and then T would be 0, right? We get A equals A. That doesn't help us. We know A equals A. Okay? We got one more shot. Let's plug in the other one that we know. Okay. let's see. So instead of B, we're going to plug in 3A and then A, E to the 4K. So I use the last dot. I plugged in the last dot. Well, normally what I would do is I would divide by A. So let me try that. What happens when I divide both sides by A? They cancel out. That's nice. So I don't have to deal with an A. That was the problem earlier. I had to deal with an A. Ooh, A's are gone. Change that to log. Log base equals log of. So log of 3 equals 4K. Natural log of 3 equals 4K. Divide by 4. Now we're talking. So now we got K. So let's plug in what we got. So we got B equals A, E. Now we know what K is. T. So now what am I going to do with this guy so that I can solve for A? One more step. What am I going to do for this guy? Plug in the first thing I plugged in, right? Plug in 12 hours for T, 10 million for B. Because if I plug in 10 million for B, 12 for T, there's only one variable left. Hey, solve for it. Okay. So you get 10 million equals A, E. So when I multiply that, it's actually going to be 3 natural log of 3. Divide this by 3 natural log of 3. And you get A. Okay. So just put that in your calculator. And you were done. And just make sure it goes with what we have so far. You can check it on your own because it triples every 4 hours, right? It triples every 4 hours. So from 0 to 4 it triples, from 4 to 8 it triples, from 8 to 12 it'll be 10,000 when it triples. Okay. All right. Yes. Say again. It comes out to a whole number. This part on the bottom here. That's fine. Yeah, that's yeah. Okay. Okay, so the assignment that I gave you, that's the assignment that goes with this. Okay. Hang on to it. I will give you time in class to do it. Okay. So I'm going to give you tomorrow. We're going to go tomorrow. We're going to kind of pause. We're not going to go on to the next section, and we're going to do that in class. So don't do it for homework tonight, because if you do it for homework tonight, I have more work to give you. I don't want to give you that more homework. So promise me, this is the only time I'm going to tell you don't do homework. Save it for tomorrow. We'll do it in class tomorrow. Okay?